Good morning, everybody. Welcome to the latest in the SESAR Digital Academy webinars, which we've covered a variety of topics, and there's more to come. This is, in fact, the first of a pair of webinars on the subject of virtualization, and in fact, this one is purely looking at the subject of remote towers. We have an interesting discussion for you today, comprising three presentations, and I'll get to the experts very shortly to explain what's going on. Just so that you know what to expect, I'll have this short introduction with a few slides, and then there will be some presentations by three different speakers, and there is the possibility to ask questions through the tab on the right of your screen. And if you wish particularly to have a question asked, that's the best place to put it. And if it's very specific to a particular presentation, we'll ask the question at the end of that presentation. If it's of a more general nature applicable to all our remote tower work, we'll do it at the end as a kind of a mini panel session. So with no further ado, I'll get to the introductory slides. I thought I'd start by introducing some very basic principles which you'll need to understand. So first of all, the basic question: what is a remote tower? A remote tower is a geographically independent facility from which aerodrome ATS is provided principally through indirect observation of the aerodrome and its vicinity by means of a visual surveillance system. This is directly analogous to a standard visual control room from which you can survey the tower in front of you. So that's a single remote tower. Now, a remote tower module is actually a combination of the systems and constituent parts from which remote aerodrome ATS can be provided, including one or more ATCO stations and the visual presentation. This is distinct from the tower itself because it is possible for a module to have access to one or more airports in front of it, which leads us on to the next one: multiple remote tower module. A multiple remote tower module, which enables the possibility to provide ATS to two or more aerodromes at the same time. So to be clear, that's one controller with a module in front of him able to provide services to more than one tower simultaneously. And then to the final concept of interest to us today is the remote tower center, which is a facility housing one or more remote tower modules. And these modules can be standard remote tower modules or multiple remote tower modules. This offers the possibility, something somewhat akin to an air traffic control center, where you have multiple sectors. Here you have multiple airports controllable by the modules. So how does this fit together? If you look through this slide and just take to start with one of the blocks of the three on the left. The left there shows three. It shows on one module down the bottom there, and to start with, you could have a direct one-to-one connection between one of those remote tower airports and the module, or three of those together. Now that becomes a multiple remote tower module. If then you have three, as shown in this diagram, separate remote tower modules, these can control either pre-configured groups of remote tower airports, or indeed the later stage in the research we're getting to allows this to be dynamically and flexibly allocated across a number of remote tower modules, depending on traffic load, controller qualifications, and a number of other factors that we'll hear about later today. This is clearly very much more complex than just a single remote tower paradigm. So how did we get here? Well, SESAR has been researching this for a very long time, since the very beginning of SESAR, in fact. And we have the SESAR 1 did, if you like, the groundwork. We had remote tower services for small airports, then for medium traffic volumes, and then we started to introduce the multiple concept with two low density aerodromes, but also to provide remote tower services to enable contingency operations. This is all validated and delivered as solutions in SESAR 1. Now in SESAR 2020 Wave 1, which started in 2017, January 17, we actually have the validation of remote tower services for multiple aerodromes, much more complex, and that was validated at the end of Wave 1, which was at the end of last year. And similarly, we started to expand the possibility to see how the kind of technologies that were being developed for remote tower and in other related fields could actually be applied to air traffic control with our exploratory research project Retina. And we'll hear more about that and the follow-on work later. In SESAR 2020 Wave 2, which started with the beginning of this year, we're continuing the research. Now we're looking with multiple remote tower into remote tower centers, but also the development from Project Retina, looking at virtual and augmented reality applications for tower operations. So that sets the scene of how we got here, and to present more on the last current element of where we are, we have three speakers. To start with, we'll have Niklas Gustafsson. I'll give a full introduction before each speaker starts. He's from Saab, and he'll be talking about multiple remote tower and centers, followed by Ramona Santarelli, who's coming from ENAV, and she'll be looking at the new technologies and ongoing research. And finally, we'll have Csaba Gergely from Hungary Control, who'll be giving us all a story of an implementation success story in Budapest. So, like I said at the beginning of the descriptions, we have here questions at the end of each presentation, maybe, but most questions will be taken at the end. So, with no further ado, I'd like to hand over to Niklas Gustafsson for the first of the presentations.
Thank you, Robin. I'll let Remy run a little short video, and then I'll start my presentation.
Very good. Can I just do your short biography to start with? Niklas is the Vice President, Business Development and Governmental Affairs with Saab Digital Air Traffic Solutions in Sweden. Niklas is a trained systems engineer and commercial pilot. Starting with flight inspection, he's worked in many positions in LFE, the ANSP of Sweden, from manager of LFE research and development and various support functions to international contracts and commercial development and commercial... Oh, Remy?
Broughton 607 Echo, landing 34, taxi to April, backtrack and taxiway Alpha.
Taxi to backtrack Alpha, Broughton 607 Echo.
Welcome to Salem.
Thanks so much.
So, Niklas, did the presentation show, the film show?
Yes.
Very good. So, Niklas, if you would like to present, that would be very good. Thank you.
Yeah. All right. Thank you for the introduction, and I'll give you a little brief on the work that's been done with the help of SESAR through the years for Saab and for LFE and many others, and the center of towers and this digital future. What you just saw was the first landing at the new built Greenfield Airport up in the mountains of Sweden, which was put into operation last Christmas, or this Christmas, I should say, which had no tower from the beginning, but it started like, digital from its birth and so on. The weather was not that good, but it worked anyway. I'm going to talk about that. The tower here, as you see, the tower is not longer in front of the buildings or terminals. It's a little bit on the side, like a mast with cameras and the eyes of this, as Robin introduced you to. Is one of the things that you may not also have to have a tower taking up space, which is used for other commercial areas and so on. And as you see there up to the right there, the camera house in this case is a winter landscape, but it can be hot or humid or dust or smoke or whatever, it is important to have a very environmental handling of your cameras. These are the eyes. That's the core of the safety of the system. Just before we continue to that, I think when you look at this, and when it started even in SESAR 10 years-ish back, it had a very clear idea on replacing towers and efficiency and so on. But I think looking at it now, with the new ATM landscape taking shape, with the environmental, the communication of 5Gs, the electrical flights, autonomy, and drones and so on, I think from our side, and I think that sort of reflects also in other SESAR work, it will have a different thing. You will have a digitalized capability in your center, which has access to a lot of information from various sources. And I think, I don't know all the answers, but I think that has a beginning of helping not only the tower services, but other services as well. And not to say that the generation of people who are digital from birth and the role they have in the future of air traffic management. Well, this is again driving the digital change from, as we think, the fixed on-site things where you have staff, which is they are flexible from their perspective, but very unflexible to handle in the wider context. You need to train them, and you need to focus to get a culture that is sort of part of your big company or ANSP of a country or a region or whatever. And then moving into the centralized functions where you may have sensors and cameras on site. You centralize your tool. You have a staff which is serving maybe more or they will serve more airports than one. You have a digital environment which looks exactly the same for every airport, more or less. You can share information. You can have training integrated in that center or remote tower centers and harmonize your procedures and culture. So it's more than just technology. I think it's driving a little bigger mental change in the way we can do it. It takes time, but it's getting there. This picture is from the first sort of airport that went live, which was preceded by a lot of work in SESAR. And here you can see the controller. She's working with it as a normal tower, but he has a compressed field of view and can look at things without need to turn the head and so on. And then the automation is pretty much like the normal thing. I think what is happening now is that things are changing. You will see it, and more information gets up to the screens and so on. But it's a digital working environment, and I think that's the interesting thing. And her colleague beside her has a similar view. This is how the next generation that we are working with look like. We twisted it, turned a little bit, improved things, and make it more industrialized so we can replicate it and be flexible in moving it. This was the last one that got introduced in another airport. Same thing, just different airport, different camera heights, different type of runways and so on, and looking at it. But it's basically getting to a point, I think, where it's accepted, and the controllers has a way to work that they now trying to understand with the help of SESAR, and what you will hear later on, how AI and other methods can start to be introduced into this and to improve the operation. So it's a journey. A little bit of skylining. This is, of course, the way it looks from a SAR perspective, and there are different brands of this. But yeah, there are, from the left, the remote tower in London City, how that will look like sort of architectural thing, to the other thing, which is more the standard industrial sites. And the thing, it takes you maybe 2 weeks to put up a tower and get it connected, while building a permanent tower, in most cases at least, take more than 2 weeks. So it's sort of also a way of how you can introduce new technology in a slightly different way than the long-term or traditional way of doing it. This is maybe another thing. Now, this is Saab also had an early thought, well, if you do technology, can you also be a service provider? So we've been working to exploit. It's a little bit of a research and testing. Can you merge these two so that there's a new business model that can also be in a way that both delivering technology and offering a service to the airport, rather than just service and technology as a side thing. They are combined. Just a way to see how digital evolution can change also other things than the purely technical or operational. Just took a little thing where we are at these things, and a lot of these things comes from the SESAR work of how a center should look like. I won't go into all the bits and pieces, but you can see here that the things that you combine the large airport with smaller airports. you can have spare things, and you can have integrated training, and a lot of common sort of functions, like you interact with the airports. There's a lot of things now on how you manage the cybersecurity breaches and so on, and that you can have centralized for many airports and save costs and so on. And in the future also, most likely, how you can have UTM control of that for the airport, and then maybe even breach of the entrance. Sort of that's a center thing that we see emerging now in many places. Absolutely fantastic work going on. Yeah, we started in Sundsvall. The first thing that after SESAR was to run this center in Sundsvall, and now we also operate it as Saab there. But it's spanning the same basic ideas. Goes to the new center in Stockholm, which is purposely built near the ACC, so they also share their information and so on, and resources with the en route centers. Just an interesting concept that all of a sudden there's two centers, both for en route and towers, and I think we learned that many of the things from en route experience can be fed into the tower part. And we also work with a similar concept with the Dutch. Fantastic work to do a rollout in the Netherlands. Also combining a lot of the SESAR work. I will not talk too much, but post-COVID showed a few things leading into this multiple airport control, that if we have had everything working properly, we didn't plan for the COVID either, and the multiple airport controlling 2 or 3 airports at the same time, we have been really much better in terms of doing with staff, and we could have less vulnerability and less impact of that. I hope Csaba maybe talk about this a little bit, but it's absolutely clear that in this post-COVID, we need to look at the resilience and the availability and keeping your staff up to speed in a slightly different way maybe than we anticipated before. Leading to that is multiple airport control. From our side also, keep on testing. These are from last year's work with multiple airport control, and it's actually growing up. This is from the research side. From the product side, it's actually finished and due to be in operation as soon as COVID releases here. But I think there was a very important thing. These are the groundworks over the years and reports and absolutely good academic results that led to understanding these pieces when it comes to real operations, and how one of the things I just mentioned is to split and merge. Sometimes you can do 2 at the airports at the same time, or 3, but you may sometimes something happens, you need to go back and only operate 1, and I think that's been one of the biggest sort of areas to look at, that is sort of something you can do on a regular 24-hour a day basis, and then things how you do your PTT, and so also to the down right here, how you plan your services over time, sort of a capacity balancing when you run a center. And of course, I mean, if you look at the first picture with the lady there, there was one airport. I think this is what you can see in maybe small and low dense regions, is that you probably will operate 3 of them with different services depending on the time of the day, and be flexible to use that. And do more with less. I think that's a key thing of this work, and I think that has been proven over the years. It's always a mental barrier to accept it, but it's actually being tested by X hundred controllers, and yes, it works absolutely. Just a short industrial perspective, COVID has an impact on this. I think we've seen different and a lot of more talks about, and most likely the release of the traditional tower and the growth of the digital tower will probably go faster because of that, and that's a clear indication at least, and let's see how it turns out. Well, thank you, Robin. That was the presentation, and I'd be more than happy to take any questions later on.
Thank you very much indeed, Niklas, for a very illuminating presentation. We have no questions posted to the page yet, so unless there is a burning issue, I propose we move on to the next speaker. And I'd like to introduce Ramona Santarelli, who is an aeronautical engineer working for ENAV Research Activities Unit. She's been involved with SESAR for 10 years. Has been around for some time in this exciting program, and she's been the leader of SESAR 1 Work Package 3, Validation Infrastructure Adaptation and Integration, a transversal thread focusing on the verification and validation platform engineering activities. She was chair of the SESAR 1 System Engineering Reviews, aimed at the assessment of verification validation platforms, readiness for the execution of V3 validation exercises. And in the context of SESAR 2020, she was work package leader of Validation and Demonstration Engineering Project, leading the design, development, and implementation of the systems engineering data management framework to support the coherence and delivery of all SESAR solutions. Since last year, she's been involved with Project 5 Wave 2 Digital Technologies for Tower as leader of Solution 97. HMI interaction modes for airport tower, and that's the subject that Ramona would like to talk to us today. So Ramona, please.
You are muted.
Oh, sorry. Thank you. I think you can see the presentation on your screen.
Yes, but just not in full screen mode yet.
Okay.
Better, that's good.
So, if we look at the evolution of the air traffic control tower over the last 6 decades, we can see that the general layout of the tower has not changed a lot, while the interface has been deeply modified. So the introduction of many information in the head-down layout has resulted in has progressively pulled away the majority of information in the head-down view and pulled away the view of the controller from the head-up view. So let's imagine what the novel and augmented reality technology how can they help us? They can offer the opportunity of moving the information from the head-down view towards the head-up view, directly on the out of the tower field of view of the controller. This can be possible through some synthetic transparent overlays that are registered to the real environment. Such tool can be synthetic vision tool that have been already partially investigated in the past, and can result in an enhancement of the human side capabilities that is not anymore limited by the human side capabilities. Let's think about what can happen in a very foggy day in an airport, and how the augmented reality can help us by, for example, displaying the runway borderlines or taxiways or parking stands. Can be very helpful indeed. So furthermore, we can display in the through the synthetic vision tools information related to the airport traffic or to each airport, such as attaching some tracking labels that can directly provide information in the out of the tower view to the controller. This topic has been investigated in the past in SESAR Wave 1 project. First of all, in a Retina project that was an exploratory research project in which two types of synthetic vision tools have been investigated. And in the frame of Solution 97.1, we are progressing with these validations. In Retina, two types of equipment were investigated. One as a synthetic vision tool, the spatial display, that is a display that is coinciding with the tower window, and in which some static feature as well as dynamic features were presented to the controller, and on the other hand also the so-called head-mounted display, that is a sort of glasses, wearable glasses that the controller can use to visualize relevant information in the field of view of the out of the tower. So the head-mounted display is used, and it works combining a 4D model of the airport, including information coming from sensors or dataset. One of the assumptions is that, for example, the weather information are always available in the system, so we can display features such as the runway visual range, or the runway layout, or the ceiling of the clouds, the QNH, and so on. We can mix these information and display them into the by means of an overlay that uses the augmented reality in order to have a combined view that is displayed to the controller. This results in an enhancement, as I said, of the human sight capabilities, and in a more easy availability of the information. So the controller is much can take benefits from this technology by means of an enhancement of situational awareness. We have 3 validation exercises in this solution. One from ENAV and Uni Bologna, one from ENIREN, and one from NLR. So we address also different size of airport. And as I said, we will validate the virtual and augmented reality and tracking label through the head-mounted display. We can project a part of static information of the airport and a part of tracking labels relevant to the airport traffic. We can also present some safety alerts, such as runway incursion or stop bar violation, or alerting, and so on, that are given in the direct field of view of the controller. And this can also be investigated through the attention guidance. So apart displaying the safety alert, we can also guide the attention of the controller toward these safety cues. Attention guidance can be, of course, measured through reaction time or through attention distribution. So there is some kind of eye tracker to understand the attention, if the attention guidance is working, the attention of the controllers. Last technology is about the air gesture. So the head-mounted display comes with some native air gesture that can fit the airport environment, I would say. We need to investigate, but there are some native air gesture, very simple, that the device can recognize, such as air pinch or air tap, and this is meant for the time being not yet to provide clearances, but just to interact with the augmented reality informations. Expected benefits are so far measured with ATCO efficiency and productivity. So what we expect is that reducing the workload per flight, the number of flights can be enhanced with the same workload, especially in low visibility condition. Another key performance area is the resilience, because especially in low visibility, we can avoid to lose airport capacity due to removal of low visibility procedure restriction. We expect also indirect safety impact due to the overall increase of situational awareness. And we also expect to address the human performance and to understand the user acceptability of the solution through cognitive indicators. We need also to address the trust that controllers have into this kind of technology. But overall, we expect an increase in information accessibility and situational awareness that should help the controller to reduce their workloads and to enhance the throughput of the runways. I would like to share with you a video that is available on the Retina website, that is available also on the internet. I think that Remy is going to project him.
KLM 1584, taxi holding point Alpha runway 12, report ready for departure, number 2 after ANR. Air France 100 Tower, clear to land, wind 070 knots.
So in this video you can see the results of Retina project, in which a controller is working with the spatial display in the virtual environment was presented directly on the platform display. And it seems stopped. Can you? Okay.
Rainer Alpha to Mike Delta, buongiorno, startup approved, and startup and pushback also approved, report already taxi.
Borderlines of the taxiway and the runway, plus the
Rainer for Mike Hotel today, startup and pushback approved,
head-mounted display. So it's a wearable device in which the controller can see the augmented reality directly on the wearable display.
Safety autorizzato ingresso in pista 12 da intersezione eco.
As you can see, the controller is not looking at the head-down systems anymore, at least very much less than before. So it has the information directly on the out of the tower view. And that's it.
Thank you very much, Ramona. We have had some questions, and we did have one which is specifically for your work. So I think we'll take that one now, and then we'll move on to other questions towards the. In fact, there are two questions we'd like to take now, if you don't mind. The one question was, how did the controllers accept wearing the headsets? Did you do any long duration testing over several hours, for example, for a full shift, accepting that these would be a series of smaller periods of work?
So the wearing headset was already tested in Retina. There were some runs of about 40 minutes. Situational awareness seems to be generally enhanced. At least this was the results of the Retina project. So the controller seems to benefit from this technology. The information accessibility was increased in the both spatial display and the head-mounted display. The drawback was represented by somehow a sort of increase of physical workload, because maybe they need to get familiar with this kind of technology, trying to cross-relate the information that they are used to control in the head-down display. So what was the results of Retina project was that accessibility, throughput, and head-down versus head-up display was reduced. So that there was an overall benefit in this sense, with the drawback of an overall slight increase of the physical workload. So I don't know if I have answered your question. There are meaning to accept mainly you need to know the measurement or some qualitative questionnaires. So we had different kind of results.
Very good. Thank you very much, Ramona. I'd like to ask you one more question before we moved on here. It's about the technology. We have a question: what are the direct advantages of using a headset as opposed to projecting the information directly on the screen?
So it's a matter of I think technology. The headset is actually a commercial off the shelf and has been proved in different technological fields such as medicines or whatever. So we are going to validate into the air traffic field as well. And it's more easy because it's the spatial display. As far as you use it into a validation environment, it's easy because you can provide the overlay directly in the platform display of the tower, while when you will be in the tower, in a real tower environment, you should have a very big display that overlays on the tower window. So I guess the direction is the direction of the research is toward the head-mounted display for a matter of feasibility. That seems to me much easy.
Very good. Thank you very much indeed, Ramona. We're getting a number of questions now. If you have asked a question I haven't replied directly, don't worry, we will get back to you as best we can. Some of the questions, there are some themes coming up. Some are on regulatory issues. It seems to be quite interesting at the moment. So so if I'd like to ask the speakers to be very aware that these will be asked about regulatory issues as well. Oh. And just so, before we start talking about the questions properly, we'll now move into our final presentation today, which will be presented by Csaba Gergely. And I apologize for the pronunciation of your name, Csaba. Hungarian is not one of my languages, surprisingly. Csaba is an air traffic controller and former tower manager with Hungaro Control, the ANSP of Hungary. His current position in the company is Senior Advisor to Director of Business Development. Csaba has over 30 years experience as an air traffic controller and also served as head of tower for more than a decade. He has followed and shaped the deployment of Hungaro Control's remote tower facility from the first day, and as a still active ATCO, has first-hand experience with the advanced technologies that enable the Hungarian air navigation service provider to enhance safety and efficiency even during the COVID crisis. He's actively participating in numerous SESAR projects and is at the forefront of ATM research and development. So Csaba will be talking to us today about that Hungaro Control project in Hungary. So with no further ado, Csaba, please.
Well, thank you very much, Robin. Good morning, ladies and gentlemen. I made a quick look through the audience. There are many colleagues and friends from other organizations, so welcome everybody. Although we are talking about the remote tower technology as the technology of the future for the aerodrome air traffic control, I'm telling you a story today about a history, because this project in our life, in Hungaro Control's life, is a historical project. Started back in 2013, when a decision was made to implement a remote tower facility for the Budapest airport. What were the origins to run this project, and why we started to move towards this direction? Well, you can see we have a very iconic building at the airport, the tower building. I can call it as a second home for me. I've been working there for more than 30 years now, and the building is even older than 30 years. And that created a few problems for us. We had some issues in the past, 2 major blackouts in 2012 and 2015, where it became very clear that the building itself has to be refurbished, and we had to look for another solution, a solution which will enable us to provide the service uninterrupted and guarantee the level of safety for all the aircraft and the passengers. So we had to analyze the situation, and it is very quickly became clear that the uninterrupted service during the refurbishment of the tower building is not feasible. Therefore, we had to look for other solutions. Two opportunities were at the time available, or we build a new tower building somewhere in other places at the airport or outside the airport even, or we can choose new technology. At the time it was very newborn and unmatured. This was the remote tower technology. We analyzed all the possibilities, but finding another spot at the airport or close the airport where we will have the same visual surveillance availability what we do have in the tower now, it was not feasible. Therefore, we had to go to a completely new direction and start to discover this new journey. What are the specialties of the airport? What were the risks and constraints we had to overcome through this project? The airport territory is quite large. In square meters, the territory of Budapest Airport comparable to London Heathrow, although we do have way less traffic and way less buildings and taxiways in this land. But to cover for the ground surveillance, this territory for the camera system is quite large. The tower building is located in the middle of the territory, middle of the airport, in front of the major terminal, between the two runways. As you can see, we have two parallel runways. The farthest thresholds more than 3 kilometers from the tower, which is a quite large distance. And even in good visibility, it's difficult to see the details in that distance. The tower service is very well equipped. We do have a fully operational ASMGCS system with 3 primary radars covering the whole area. So we do have radar coverage at all the spots of the movement and the maneuvering area. Also, the ASMGCS system enables us to provide the service during any visibility conditions in LVP or any other difficult weather situations. In the tower cabin, we have not 1, but 5 air traffic controller positions. We do have tower controller, ground controller. We have clearance delivery, which is not a continuous sector to open, but time after time when we have many departure traffic, we have to open to serve the pilots well. Then we have a so-called planner position, which is which has a main role in snow clearing operations or emergency situations. Its main task to deal with the ground vehicle traffic and to help the tower and the ground controllers in coordinating with the ground staff, airport services, or other neighboring ATS services. Of course, we do have a supervisor position as well. So these positions we had to copy into the new facility when we designed the remote tower cabin. In the tower cab, we have a quite sophisticated major ATM system with FDP, and more than 15 years now, we have no paper strips, no electronic flight strips. We do only have flight lists in the ATM system, and all the traffic data exchange and radar data exchange and radar handover between approach sector and the tower is ongoing, which enables the controllers to deal with the traffic intensively and not care with the data exchange in any conditions. Also, we have the ground systems like ILS and ground lighting control, fully or semi-automated. So with the single clicks, we can change the direction of the ILS or turn on or off the ground lighting systems for the runways and the taxiways or the stop bars as well. So the air traffic controllers in the tower cab are very well supported by automated systems. How we implement and how did we design our camera system to support the remote tower facility? Well, the first step was to duplicate all the running and existing systems in the tower cab and put the HMIs into the new facility for the remote tower and be able to control and have all the data necessary for the control in the new facility, which meant a completely new location outside of the airport territory. So the servers, the data links, and everything had to be built for this purpose. Then the video wall and the camera system. Because of the large area, we tried to go into a direction to provide the air traffic controllers with the visual data, visual information as further as possible, even in reduced visibility conditions. Therefore, we decided to use not only the out of the window view, but according the current infrastructure availabilities, there are more camera points at the airport, which is not the final system, but at the time, these were the locations where we had the needed infrastructure. So there are 3 camera positions at the airport at the moment. We can have a view provided to the controllers, not only from the tower cab, but 2 other positions closer to the runways. The next step was to integrate the ASM-GCS data with the camera systems. Therefore, we could have automatic labeling, and now we have an automated tracking function as well for the PTZ cameras. Having the visual surveillance not by natural view from the tower cab through the window, but using cameras, it obviously needed to have a paradigm shift into the ATCOs, and there was a separate human aspect project run parallel with the technological project to help and support the acceptance from the controller side. this was a major, it had major importance later on. So the camera system was distributed, and we did have PTZ and fixed cameras, dual sensors for the PTZs. You can see not only the visual picture, but the infrared picture as well. And thanks to the automatic data exchange between the SMGCS data and the camera system, we do have automatic labeling, which helps a lot for the controllers in difficult situations. And of course, beside the PTZ cameras, they have the opportunity to set individually hotspot pictures and hotspot presentations. Here we can see the controller working positions in the remote tower cab. You can see many of displays. To be honest, at the time, our systems were not mature enough to go and to use them into a remote tower cab, but the low level of integration will be changed in the close future. We are running projects to integrate the systems and reduce the number of monitors. But the system with the minor upgrades is up and running since 2016, and it is capable to provide live service. We have now stages of implementation, a strategic program within Hungary Control. You can see in 2016 we ran a SESAR very large-scale demonstration, and that was the purpose to build that facility. And with the minor upgrades, that system serves the remote tower up today. Later on, we are planning already the system as a parallel with the current remote tower to design a new facility, which is now an ongoing project within Hungary Control. So we could have 2 remote tower facility, and then we can be in a position to make a decision to leave the tower or not. That's going to be in the future, but for the time being, we have very good results, outstanding, and I can say that the leading experience running a remote tower for medium-sized airports. Now we have more than 2,000 hours of live operations under any other, more than any other ANSPs in the world. And we have controlled more than 12,000 movements from this remote tower cabin, most of them in good visibility, because in good visibility we can use the cameras. In LVP there is nothing special. We can use the SMGCS, but in LVP you can see it anywhere in the world. If you have any SMGCS, you don't need the cameras. So it doesn't, oops, sorry. Yeah, so we run this remote tower facility not only in good weather and normal operations, but we serve emergency situations, training flights, airspace, and airport restrictions. During the COVID area, we had a special rostering to provide needed separation for the controllers in between the shifts. And in these times, the airport went out under major reconstruction works. So we did have runway closures, taxiway, and even apron closures. So it was a difficult time for our controllers, but we did it quite well. We gathered a lot of experience in this field to design a remote tower. And of course, the remote tower is the future of the ATM, in the tower ATM, and we can help other ANSPs, airports, how to implement without major cost burning projects, how to implement a remote tower successfully. Well, that was my short presentation. Thank you for your attention. Robin, you are muted.
Yeah, I am just finding my unmute button. Thank you very much, Csaba. A very, very interesting presentation showing that the research is finally getting us into the deployment, as we saw also in the presentation from Niklas. It's really quite exciting to see the work turning into something and being so successful and so valued by the participants. Thank you very much indeed to all the presenters today for three very interesting and quite different presentations, which cast quite a good light on the state of play in both research and in deployment. So thank you all very much indeed. We now have about half an hour, which I would like to spend as a kind of a mini panel session. Behind the scenes, I've been trying to organize some of the questions, which are pouring in thick and fast now. So I will do what I can now to try and put some order into the questions. For those making questions, if we don't get to ask your question specifically, don't worry. What we'll do, they are recorded, and we can make sure that we get a reply posted to these questions after the event. But I hope we'll be able to get through quite a number of them in the coming half an hour. Now, I've been trying to sort some of the questions by theme to try and make the best use of the full panel in front of us today. And I'd like to start with the questions that we had on regulation. So this is probably aimed more at Niklas and Csaba, but I'd be interested to know also if Ramona has looked at the regulatory side of this. But the questions are looking about what are the regulatory barriers and legal issues that we have to address when trying to deploy remote tower solutions, but also in this environment, what is the role of the EASA, who's only produced guidance at the moment, and what are the plans for ICAO to become involved? So could you cast some light, please, on the regulatory, international, global regulatory environment, as well as the more local issues you had? Maybe Niklas, you could start on this question.
Yeah, thank you. Yeah, I can. I mean, at the outstart, I think of this, one of the ideas was to, and you can see it in the in the implementation, not to change everything at one time, but to sort of try to mimic the operations as they are today, and then introduce technology and procedures that are digital and remote. And maybe if we sit here in 10 years' time, it will slightly different. So the basic framework, I think, stays pretty much the same in terms of Doc 44, 44, and so on. That said, I think there is an ICAO. If you start at the top, there is a task force or a group. I don't remember exactly the name of it, but it's sort of it is a, they call it panels before, but they will be on top of that on a global scale, activities work done there, and then going down to the technical part. I saw maybe Jörn was here about Euro-K on the technical standards, which has been a lot of work, and trying to at least find the minimum principles so that it doesn't go away, that every technology is going in different directions. And I think they have done a good job in trying to keep it in a fairly standardized fashion on the technical side. And then you have the of course the EASA, which is guidance material. I think it's the second iteration out, which has sort of also homed it into this, and they're building a lot of this SESAR work that has been shown here as a way to underpin the guidance material from that. And then of course the EASA is still in Europe, and it's different in different places of the world. Of course, it's a national regulator who gives the final approval of the systems and so on. And I think that's what the guidance materials is definitely supporting that part. That aside, then there are other sort of groups trying to help to find best practices, like in CANSO and so forth. Before Csaba here, my experience is that sort of the barriers that you foresee is sometimes you say there's the regulator. Yes, there's a fair amount of basic validation. Can you work on a digital screen? Can it be shown that it's safe, or as it is today, or even safer using that? What is the backup plans for that? And that's I think every implementation, I think in Hungary control, or in Sweden or UK, has gone through the steel bath of doing all these kind of things, but because the book has not been written yet on how many times you have done it. Then I think the main barriers has been, I think, working on the acceptance from the users and from the community as such, that you need to sort of try to understand, is this safe? It might be the of course the air traffic controller, but also the airports and the airlines and so on, to make sure that this is acceptable. And I think from all of us in this, safety first, there's no way at all you can even think about jeopardizing the safety here, and taking very small steps in order to make this happen. To conclude, I don't think the regulatory is a major barrier at this stage. It's for us to handle the regulatory framework, support it, and so on. And that's, yeah. Over to Csaba.
Csaba, please, you're muted. Oh, okay.
Thank you. Well, we were in a very, I would say, easy situation back then when we started the design phase of our remote tower facility, because there were no regulations and no requirements documented at the time. However, we decided to go on work in a close relationship with our NSA and with EASA, also to get know what would be the future requirements, what would be the future regulations, and we provided support to the authorities in terms of we let them know well in advance what are our plans in procedural, technological, or human factor related questions. Therefore, we gone through that way towards the regulations and towards the guidance materials together with EASA, together with our NSA, and still today we are working together with Eurocade in what Niklas mentioned, the Working Group 100. Hello, Jörn. So yeah, we are working in these organizations to create and provide help for the regulators, for the regulations, and for the guidance materials. We are aware of the importance of this kind of work, and try to design our future developments in alignment with the future regulations and requirements.
Thank you very much, Csaba, and to Niklas. Ramona, do you have any thoughts on the regulatory issue for the maybe the kind of headsets you're looking at? Is there any regulatory implication for this kind of work?
No, for the time being, we are addressing TRL 4. We are focusing on the feasibility of the solution, and we are not focusing on the operational impacts on procedures and so on. So we have not progressed so far in this moment. So
okay, fully understood. Thank you very much indeed. Okay, I'd like to move on from the regulatory side. What I'd like to do is now move on to the performance side. We had several questions looking at the performance of the systems. So once again, I'd like to talk about the various elements that are raised in the questions. I'll ask them all now, and then each of the panel members, if they'd like to raise their particular interest. So one question was asking about, was there any latency involved with the image being received in the remote tower modules? And then one for Ramona, was there any parallax issues if we were using a screen-based solution? Did we have any security side, like poor ground connection, losing the camera signal, or jamming or spoofing of any system? And also, if we're looking at this performance, how are we going to start working on the performance standards like continuity of service and contingency plans? How are we addressing these particular issues? So maybe I could start with you, Ramona.
So I'm not sure I take your point. And
about parallax with the when you are using a screen for putting up the supplementary information. Was there any parallax issue with the controller moving around the tower, for example?
no, as far as I know, was not. The spatial display and the mounted display, no, they don't have any drawback in this perspective. So they can move as freely, and they are not limited to the head-down layout of the information. So they can move as you can see in the video. And I think they feel more free to interact also with the interface.
Okay, thank you. Niklas?
Yeah, these are always the questions, and I think starting with the communication, I think, yeah, of course, this if you do it remotely and not maybe at an airport, you need to have solid communication. I think that's fair. Most of the installations we've done has dual sort of high-speed fibers. Some has 3 because it's sort of the level of continuity and the resilience you want to have. Another thing we learned is that most likely you can have the picture, but the key thing is the voice, of course. You need to make sure you have your voice backed up accordingly so you can degrade your system. And I think a lot of the work moving into operation is not about the screens or the gadgets you can see. It's about having solid, proper fallback procedures, how you do if this happens and if this happens. That sort of occupies a lot of time and understanding, and that how that feeds into the safety case. Then the contingency, of course, the center as such, you can see, you can allow yourself to have a better, maybe it's not just one tower, you can have the very good sort of redundancy both on the hardware and the software and all this kind of in the center, and build that in, and even adding cybersecurity sort of filters and things on that. But I think there is a little bit of an open end, and I think we will see it being researched. Can you sort of hand over to Csaba from Sweden and back and forth? How can this interact in between? I think it's too early for me to say that that's easy at this stage, but because this involves a lot of personal licensing and so on. But some point in time, when you start to do cross-border, you may try to find that, or in a country you can have two centers working together and all these kind of things. I think these things are the essence of making this trustworthy, is that you have a rigid sort of safety and fallback procedure all the way down to the individual sitting there. And there was also a question about, do you see if something happens? Yes, of course. The alarms, the difference between maybe a normal tower and a digital tower center is that the way you present alarms and events, you need to deal with them slightly different than in the traditional tower. So most of the training is about managing if something happens on that. That's the only major difference.
Lovely. Thank you very much, Niklas. And Csaba, on performance issues, how have you found it in operations?
Well, as an air traffic controller, I can tell you only the user side of the system. But if we take into account that the data transferring part was not even designed to deal with this amount of data which the cameras produced, and still was capable to handle the task. I can tell you that during these more than 2,000 hours of live operations, we did not encounter any major fallbacks regarding the camera systems. Yes, of course, the cameras are not the cutting-edge technology at this moment because they are more than 5 years old. Of course, we could have better images and better cameras installed, but still with these cameras we can still have a robust system, and I don't know any issues during this last 4 years of the operation, which occurred during the live operations. Of course, we did have system upgrades, minor system upgrades, software upgrades mainly, but the hardware of the system, the camera part, is basically the same. So the performance is solid and robust, but there's always room for improvement, and we are working on the next generation of the system architecture. And now in these days, the new fiber optic loops, which we've been waiting for years, is starting to be created, and then we will have the opportunity to put more camera sites along the airport. I guess we lost Robin.
We lost Robin.
Yeah, but don't worry.
I think Robin lost his connection, so maybe we will handle a few more questions. So I don't know who wants to answer a few questions that appear there.
Hello, I'm back. Can you hear me?
Yeah, we can hear you.
Sorry about that. I wasn't sure if it was just me or everybody. The system just went very, 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 very dark. So I'm sorry about that. But I'm back. Fantastic. Thank you. Sorry about that, everybody. Did we finish the last question?
Yes.
Yes.
I hope so.
Fantastic. Well done. Thank you. What I'd like to do now is to what I've kind of called support. We've had a lot of talk about the technical and the operation from an ATCO perspective. I think it's important we also look at the other side of things, like particularly engineering support. So we'd like, is it possible for you to say a few things about how we see the ATCEP role, for example, the technical support as operations are in progress? Is there any issues about the layout of a center to enable effective support, but also support services? For example, MET has been asked about. How do you deal with MET information and other information coming from external sources? So please, maybe Niklas, you could start on that subject.
Yeah, welcome back, Robin.
Thank you.
Yeah. Well, let's start with MET. I saw something, and yes, of course, there's I guess a variety of how you do your MET in different airports and different ANSPs and so on, and if you have local methodological knowledge and so on. I can only say that this was one of the things that delayed the introduction of the first things we did at the first center. It took another half a year because you need to validate doing MET's observation via the cameras and during different seasons and different conditions and so on. And right now, at least 5 of these airports, I know they do it via the cameras. Some areas we see also there's been a challenge to do that, so and maybe that's the way you used to do it. So, but I think MET, as I see it, will be done remotely from the center of the MET observations and so on. And I have never heard the last 3 years any, and I think we have over now 65,000 hours of remote tower nests from Sundsvall, and it's been working. And if there's an issue, there's always a number to call at the airport if you want to check the clear icing on things and so on, that you can do it. Normally the fire brigade to do that. Then I think maintenance and engineering is an interesting topic. I think you're right. There's been a lot of focus on cameras technologies and the way you work with the controllers and so on. And I think, to be honest, from Saab side, and we missed that a little bit, and we kept it as it was. And I think the second generation of both equipment and sensors has been a lot about how do you make this less or increased maintainability. So you reduce the amount of time you need to share at the airport. If you have a remote airport, of course, if a camera fails, which has happened only one time, then of course you have to go there and fix it, and you have to do preventive maintenance and so on. But in the center, I think, I don't know, the design of the center, yeah, it's the difference is that every module is the same, they looks the same, they have more or less the same equipment. Some may have more automation than others, so there is a an ability to make a more efficient maintenance. And then here, I think from our side, I think you need to go through that and learn from. Csaba mentioned 5 years of work. What you need to update your maintenance sort of procedures as well, and I think that's happening. Then of course centralized, you have all the alarms, you have all the information of the status in a very, very good shape in a center. So I think that there is more development to be done to make it even better when it comes to this. Whether you need a different role of the ATSEPs, yeah, maybe they will work more like in an ACC than they do in a traditional airport context and so on. Yeah.
Thank you, Niklas. Csaba, would you like to add anything?
Yes, just a short notice that regarding the contingency measures, even a regular tower, the air traffic controllers must have a contingency plan for all the systems, the fallbacks, and all the unexpected event, what to do and how to overcome that, and how to maintain level of safety. This is the same procedure for the remote tower facility as well. Plus, we had to add another system, the visual system. And at the time, we had no any experience related to the cameras, what could go wrong. So we made a very strict contingency plan. But since then, thanks God, we never used it. But yes, the contingency plan is essential if you go live operations from any remote tower or regular tower. It is doesn't make a difference.
Thank you. And do you actually have a dedicated ATSEP position with their own displays, monitoring serviceability of equipment and the status of the equipment and in the various remote sites? Do you rely on feedback from people located on the sites, or is it a combination of both?
Well, our remote tower facility located edge of the airport fence, right outside of the airport, in our headquarter building, close to the main ATM air traffic control room, where all the ACC approach and other services located. And we have a common technological maintenance supervisory staff there, with all the remote control HMIs for all the systems, not only for the remote towers, but any other. And we have a common supervisory service from the maintenance staff, not dedicated to the remote tower, but we have a tower maintenance group which deals all the systems with their what located in the tower cab, and we use the same system, same HMIs in the remote tower cab as well. So we not have a dedicated remote tower maintenance, but a tower maintenance which deals with all the stuff.
Well, to follow up from all the deliveries we made, the customer has chosen to have a technical supervisory positions in the center, which give them increased access to all the information. The controllers in front of them get a subset of the things that can happen they need to deal with from their perspective, and then the technical supervisor with 1, 2, 3 positions as they see fit and the number of airports.
Thank you. We are 8 minutes to go. Some of the questions look towards the future, and I'd like to start with these now to ensure that we cover them. Is that, do we expect the future version of remote and digital tower systems combining visual surveillance with other means of surveillance in addition to AI recognition based on visual surveillance and its possible acceptance by ATCOs? That's quite a complex question. I wonder, Ramona, could you attempt that one? Can we see a future remote tower with a combination of all these technologies supported by AI?
Well, this is what we are validating. So as I said, we are still addressing TRL4, so maybe it's the less mature technology we are addressing today. And we are focusing on the feasibility of this concept in a tower environment. So I think that actually can be very possible in a future scenario of this environment. So the technology of the headset seems to be quite mature and has been already used in other fields of applications. So we are trying to make it, trying to pave the way to make it possible in a future tower environment. And
Okay, thank you very much. And Nicholas, can you share with us maybe Saab's vision of what's going to happen in the future?
Yeah. Well, I don't know if I can everything. I think it's a valid point. I think every design decision we make at this stage is about how will it work now, in 5 years, 10 years, and 15 years, and what are the things happening around us. And I think I'm not sure about the lookout and then the way you have your headsets. I cannot say. The only thing I know, we need to look at the human factors parts and the safety parts, and the way you may introduce sort of new technologies like AI. I think definitely we will see a use of assistant guiding agents in our system that will help the controllers to do their stuff better. The video analytics will definitely move on and do that. And I also think that the center of towers is where we are thinking our idea around that will be where you have competencies sort of centralized and ability to support many towers or many operations and so on in the same center. That's sort of where we are. And then I think the systems now, what is the next generation? How do you do upgrades and so on? And I think I think we will see a period now with expansion in the number of digital towers to a certain level of technology. And then let me see, if we sit here in 5 years' time, we will talk about how will the next third, fourth generation look like and so on. But again, that's our daily thinking about exactly that in order to make sure we or our customers don't get locked into something that is not expandable or changeable. That's a very good point.
Thank you. And Csaba, could you share with us your future plans for Budapest?
Well, as I mentioned, we are now already in a design phase for our next remote tower facility, which will be an upgraded version. I can call it remote 2.0 for Budapest, which will have a completely new camera system and more integrated ATM supporting systems as well. But talking about the future of this technology and AI, AI can deal only with digitalized information. And once we are digitalized our vision, I mean the visual information for the controllers, the site, through camera systems, it's only a matter of time when AI will step into. But the question is, what tasks and what functions can AI support or even took over from the controllers in the future?
Very good.
Just want to follow up a little bit, Robin, looking what the work that Ramona presented here on looking up and looking forward. I think one of the big sort of near-term trends is to move more information up on the screen and allow the controllers to look out and this sort of look down to the table, look up. And I think that's one of the things that we see happening and more and more. It shouldn't clutter your environment, but I think it's they learn and they have these screens to use. And I think that's a near-term sort of trend that or evolution that came from the ATCOs themselves. Can I do this instead of that? And I think that's interesting that maybe Csaba's seen the same thing. When you put it in front of the professional controllers, you get good feedback. There might be an early resistance, but then you actually get very, very good ideas and things. And I think that they're moving up and looking out is the sort of next 5 years main change.
There is one important stakeholder group we haven't really discussed here very much, and there are 1 or 2 questions coming from the community, and that's the pilot, of course. They are ultimately the customer for these services. I wonder if our panelists would have anything to say about the pilot's perspective of what we've been doing. Particularly, I think there's concern about the contingency arrangements, so that should a remote tower facility fail, it might have an impact on more than one airport, which is very worrying. But also, if one controller is operating multiple airports simultaneously, will any delay there have a delay impact on aircraft at another airport? So may I ask Niklas to start on that one, please, from the pilot's perspective, please.
Yeah, I reckon the question it's not a new one. Of course, yeah. I mean, everything we do has to be approved by the safety and the regulator. So there's no system that can be put in place if there is the basic contingency. Then, of course, and as I showed you in the slide, if you do multiple airports at the same time, you have to have a way to degrade yourself, if you may, from operating 2 or 3 to operating 1. And the centers that we design is that you need to have the spare capacity to sort of say, if there's an incident in one airport, yeah, I cannot handle 3 at the same time, then I have to have the capability still to sort of offload that workload to another controller in another module. And I think that we see most of the designs or requests from ANSPs, they also want to have an extra in case something happens. So that's part. Then when it comes to if a center fails, yeah, then the airport fails as well. Sort of this center single point of failure thing. I think most areas, you do everything you can to build in these capabilities of redundancy. And I think it's the same logic. And I think Csaba agrees for the en route center. If there's probably a larger problem if the en route center fails than the central towers, of course. So you need to be very cautious on contingency and support and so on. And then, of course, if the airport is closed, if you close all the airports, yes, the alternatives might be different than it is for as it is of today. But also, an airport can close. So. Yeah, it is an issue I need to have to deal with in this evolution of remote and digital tower, for sure.
Thank you, Niklas, and I'm sorry to everybody and our last presenters. We are absolutely at the end of our time now, so all that remains me to do is to thank our presenters deeply for the contribution. It's been very interesting. Thank you for asking some very good questions, and thank you to the audience for spending the time with us today and for asking such excellent questions. I hope you found it useful and enjoyable. It's been a pleasure being with you today, and I wish you a very happy rest of the day, rest of the week. Take care, everybody, and goodbye from us all here. Goodbye.
Goodbye.